Hi, 8th grade, and welcome to your review for topic 1. This is meant to be a quick review / refresher. So if you have this piece of paper, I suggest doing it first and just watching to check your answers, because I'm going to go through it pretty quick. Samantha runs 1 mile in 10.2 with the line above it minutes. How can you express the repeating decimal 0.2 with the line above it as a fraction? Remember, this line above means repeating, so the number keeps happening. So, since it's multiple choice, we can try each of these numbers and see which gives us 2 repeating. If you do 1 divided by 2 in your calculator, that's going to give you 0.5, not what we're looking for. 2 divided by 10 is going to give us 0.2. That's close, but remember we want it to repeat. 1 divided by 9 is going to give us 0.1 repeating. Still not what we're looking for, so let's try this last one. 2 divided by 9 gives us 0.2 repeating. Sweet. That is worth 1 point. Number 2, classify each number as rational or irrational. Remember, rational means it repeats or terminates. Irrational does not. So pi is equal to 3.141592654. Keeps going. Does it repeat? Nope. Does it terminate? Nope. So it is irrational. 5.3 with the line above it. Remember that line above means repeating. So 5.3 with the line above is rational. The square root of 36 is 6, because 6 times 6 equals 36. So this terminates, meaning it is rational. The square root of 8, I'm going to double check that in my calculator, because I'm not 100% sure of what the actual number is, which gives you a hint that it's not a perfect square. The square root of 8 is 2.828427124. Keeps going. Does it repeat? Nope. Does it terminate? No, it is irrational. Last but not least, negative 3 divided by 7 gives us negative 0.42857142857 . It repeats this 428571, 428571. It does repeat, so it is rational. Any fraction. Fractions are always rational. Fractions always. Okay? So any number that can be written in a fraction is rational. Number 3, how would you classify the number 121? We have to find out if it's a perfect square, a perfect cube, both, or neither. So in order to do that, we're going to take the square root of 121. Square root of 121 is equal to 11. So it's definitely a perfect square, because that's an integer. Let's take the cube root of 11. I have to figure it out. 121, sorry. Take the cube root of 121. Remember how to do that in your calculator. You got to hit the 3 first, then second up arrow, then type in 121. So that gives me 4.94608. Keeps going. So this number is not an integer, meaning it is not a perfect cube. So it's only a perfect square. Number 4. Taj has 27 classmates, whether they know how to write calligraphy. He used a calculator to compare the number of classmates who said yes. Oh, actually, just kidding. I'm not going to go over this question. We're skipping this question. It is not on your test. Sweet. Question 5. What is the side length of the square? Well, it says area equals 169. We also know that area equals length times width, but in a square, the length and the width are the same. So we can say side times side, which is also written as side squared. So we know that side squared is equal to 169. So in order to find out what one side is, we take the square root. The square root of 169, I believe, is 13. Can double check in our calculator. Yep. So the side equals 13. Number 6, solve the equation x squared equals 26. Well, remember, in order to get rid of the square, we're going to take the square root. So if I do 26, the square root of 26 in my calculator, I get 5.099019. Keeps going. This number, irrational. Since it's irrational, we're not going to write the whole thing out. We're just going to write it with the square root symbol. Well, we know it's not 13. It's not 13. That's if you divide by 2. You cannot divide by 2. You have to take the square root. Then we have to decide between A and B. Please remember that if you're taking the square root, it is the positive and negative answer. Only on the square root, not the cube root. A cube-shaped box has a volume of 125 cubic inches. If the box is packed full of cubes with edge lengths of 1 inch, how many cubes can fit along one side of the box? Be very careful with this question. It has 2 parts. So first of all, volume is 125. Remember, volume equals length times width times height. But in a cube, they're all the same length. So volume equals side cubed, which equals 125. So to get rid of the cube, we have to take the cube root. The cube root of 125 is 5. You are not done with this question. It says how many cubes fit along one side of the box. If you picture a box, let's see if I can draw one here. We just found out that all the edges are 5. This is 5, this is 5, this is 5. We want to figure out how many cubes can fit along one side of that box. One side of it. So that's actually the area of a face. So area equals length times width, which is 5 times 5. So our cubes, 25 cubes, can fit along the side of the box. All right, number 8, evaluate the expression for x equals 1 and y equals 5. We must substitute first. So we're going to say 16, instead of x, I'm going to put a 1, plus 5, again, instead of x, I'm going to put a 1, times, now instead of y, I'm putting a 5. Now I follow my rules of PEMDAS. Please excuse my dear Aunt Sally. So I'm going to do all the exponents first. So I've got 16. 1 to the 0 is just 1. Anything to the 0 power. Plus 5. 1 to the second power is 1 times 1. So that's just 1. And now times 5 to the first power. Remember, when we have a negative exponent, we can put this over 1. We flip the exponent and make the fraction positive, or the exponent positive. Now I'm going to do my multiplication. 16 times 1 is 16, plus 5 times 1 is 5, times 1 over 5. So we still have multiplication to do. I'm going to make this a fraction by putting it over 1. So I have 16 plus, do the numerator times the numerator, which is 5, denominator times the denominator, which is 5. Now I can divide that. 5 divided by 5 is 1 whole. So we're just doing 16 plus 1. Our answer is 17. Number 9. Draw lines to connect each expression on the left with an equivalent expression on the right. So I see this y to the third squared. Remember, this is the power of products property, which says we have to multiply the 2 powers. So y to the third to the second is equal to y to the 6, because 3 times 2 equals 6. Same thing we just talked about. If we have a negative exponent, we can put it over 1, flip the fraction, and lose the negative sign. Now, the quotient of powers property says that when I'm dividing, I keep the base and subtract the exponents. So 8 minus 3 is 5, meaning next there. Last but not least, y to the 4th times y to the 4th should be y to the 8th, but let's double check. Keep the base and add the exponent. The product of powers property gives us y to the 8th. Express the number 3,440,000 in scientific notation. I know this is a big number. Big number, not a decimal, should be a positive exponent. So I can make this easier on myself right away. I know it can't be A or B. The next thing you have to do is remember to count the decimal places you move. I want to put the decimal there because it's a number between 1 and 10. You start at the end. We're going to count 1, 2, 3, 4, 5, 6. So it should be 3.44 times 10 to the 6th. 11. Rewrite 3 to the negative 7 using a positive exponent. Remember, negative exponent property. Put it over 1. Flip the fraction. Lose the exponent. Sorry, the negative. Number 12. A large oak tree has 2 times 10 to the 5th leaves during its lifespan. A large forest can have about 5 times 10 to the 3rd oak trees. Approximately how many leaves would be in the forest during the lifespan of these trees? So this is one tree, and this is how many trees we have total in the forest. So in order to find out how many leaves there are going to be, we are going to multiply 2 times 10 to the 5th times 5 times 10 to the 3rd. Remember, when we're multiplying scientific notation, we do not need them to have the same exponent. So we're just going to group the numbers together. 2 times 5 times, then we're going to take our powers together. 10 to the 5th times 10 to the 3rd. All right, 2 times 5 gives me 10 times. Now, we're using our product of powers property, so we keep the base and add the exponent. 5 plus 3 is 8. We can't leave it like this because it's not written in proper scientific notation. We move the decimal 1 and add 1. So it is 1 times 10 to the 9th power. And last but not least, find 1.6 times 10 to the 7th plus 3.8 times 10 to the 8th. Express your answer in scientific notation. When we add or subtract, we must have the same exponent, and these do not. You want to go with the lower exponent, so I'm going to keep this in my thought bubble. And I know I have to change this number. So I'm going to have it as 3.8 times something times 10 to the 7th, because that's what I originally want. Well, 10 to the 7th times 10 to the 1st equals 10 to the 8th. So remember, you multiply, you keep the base, add the exponents. So I'm going to put parentheses around this. If I move the decimal once, that takes place of the 10 to the 1st. So I've got 38 times 10 to the 7th. Now you can go back to your thought bubble, put 1.6 times 10 to the 7th plus. The whole point was to get it to say times 10 to the 7th, so I know that's my answer. And I have to add these two numbers. 38 plus 1.6 gives me 39.6. Last step, make sure it's in correct scientific notation. 3.96 times 10 to the 8th. Hope you enjoyed this quick review. Good luck on your test. You will do great.